linear letters are lapping letters. The rotational motion letters are what type of letters? Greek letters. Everybody can see that. Theta, omega, alpha, so far. Good. This basically, what we have here is kinematics of, there is only one thing, the centripetal acceleration. Before centripetal or radial acceleration, I said that is v squared over r. V squared over r. I will explain now from rotational motion what will be the centripetal acceleration. Now, there is only one thing important missing here in the kinematics of rotational motion, and is how can we connect both motion, the linear and the rotational. How can we connect both motion? Very simple. So, you can see this is a circumference. So, if this circumference is moving, imagine this is the circumference. So, let's look at this point. When this point is moving and make a full turn, you can see this point and the center of mass, right? This point and the center of mass. When this make a full rotation, this and this will be at the same point, right? When this make a full rotation, the edge and this will be at the same point, or this and this will be at the same point. So means that at a certain point, when this make a full revolution, this will make a full revolution, the same distance. In other words, if you have this, you can see this point and you can see this point. When this start rotating this way, when this make a full turn, that can be here, boom, boom, let's say that is here. This travel the same distance that this travel. You understand what I mean? So if they both points travel the same distance, and I know that when this make a full rotation, what will be the length of this point? The circumference. And what will be the circumference equal to? 2 pi r. This is what we call distance, linear, the linear value. This is what we call the rotational value. But now, let's say that this move just a certain distance. So this will move from here to here. This is what we call delta theta. Sorry. And this is what we call r length. This is theta, and this is r length, S. So I can say that S will be this section. Instead of 2 pi, what I will write? Delta theta, or theta, and instead of r change, r is this, and r is this. Is the same? Is the same. This is my linear equation for distance, or r length, which the circumference comes out of here. Except that for the circumference, this will be c, and for the theta, how much will be? A full revolution, how much? 2 pi. But it's the same thing. These are coming from here. But if by any chance this delta S change, if this delta S change over the time, that is distance over time. What is distance over time in physics? The speed. And that, if this change over the time, what will happen? If this change over the time, what will happen to the angular change? It will change as well. So when this change from here to here, the angle change from here to here. They change. So this change over the time. The radius change? No. What is this? Delta theta over delta t, what is that? Omega. How V and omega will be related? Omega r. Everybody can see that. So the linear velocity will be related to omega, like this. So if you have my hand which point will have more angular velocity, this or this? Angular velocity, not linear, angular. Angular velocity is the changing angle over the time. It's the same changing angle over the time from here to here than this one. Tell me the angle. How much is the angle changing this from here to here? 90 degrees. How much is the angle change for this point when I am changing from here to here? 90. So delta theta is the same? Is the same. So over the time, the velocity, angular velocity, will be the same for this point than for this point. For this point, for this point, for this point, for this point will be the same angular velocity, but the linear velocity will be the same. Which point will have a greater linear velocity? Which point will cover more distance over the same time? The outer point. This you can see in this formula. So if R change, V will change, but omega doesn't matter if it changes or not. All points will have the same angular velocity. This is the next. What will happen if V change over the time? Delta V over delta T. What will change over the time as well? This or this? Omega. So we get delta omega over